Hi, this is Celine the Tulip, and this is an example of using Java's built-in hash maps function. So over here I have this project that's called my patient map, and I've got just two files in here, my patient class and then the simulation that will show you how we can create a hash map of patients. So let's look at patient first. So this is just, it's got an enum for the patient status, string for name, ID, the status, and their arrival time. And we've got a constructor and a bunch of getters and setters. So that's the patient class. And in our simulation, what we are doing is creating a hash map. So right here, I've created hash map, and I'm mapping integer, which is going to contain the patient's ID, to the patient class. And I'm actually going to make this hash map the size 131. That's a nice prime number, and that should be plenty big for the number of patients we're going to be throwing in here, which is not really very many. I could actually make this smaller, but I'll leave it as it is. Note that I had to import Java util hash map to be able to use this. And then I've added a bunch of patients here. And so the way that I add patients is I do PM, which is my patient map, dot, and actually I'll just show you this. If I type PM dot, you'll see that NetBeans will suggest all sorts of different possible things that I can do with my patient map. So there's get and put and so on. So I did a PM.put, and I put in a new patient item, name John, status, and the ID is up here. It's 456754. So I'm using the ID as the key. The ID also happens to be in the patient object, but that really doesn't matter. I could put a different number here. What's really going to be important is the number that goes in here as the key to my map. And here I've got another one, patient Celine with this ID, patient Byron with this ID, etc. So I've got 6 patients in here, and then I can print out the patient map. And I do this by getting a key set, which is all the different keys that have been used. This will be all of these ID numbers. And then for each ID number, I print the ID number, and then I use the get method on my map to say, give me the value that's associated with that ID number. So let's just run this and see what it looks like. And I'll just make this down here so that it's easier to see. There we go. Okay, so you can see that my map contains a bunch of keys and values. So here's the key 456754, and it's associated with this value, which is a patient object which has these data associated with it. Okay, so let's see what else we can do here. Let's get a patient and buy an ID. So here we've got a sysout, and we're getting patient with ID 432975. We'll just call it, and this should be, if we look up there, 432975, that should be patient Abby. So let's play this, and we're seeing get patient, and it gives us, in fact, patient Abby. All right, and we can try a couple more. Here's another one, 567221. That should give us Celine. And then we should see what happens if we try to get a patient that isn't there. So the number 332908 is not actually in my mapping set. So let's run this. And now we'll see we got Abby, and then we got Celine. And when we gave our patient map a key that doesn't exist, it just returned null. Okay, so that's another nice thing about the hash map is you don't have to check first to see if the key is there. You can just try and get it, and if it's not there, it's going to return null. It's not going to throw an exception. Okay, so then we can actually also check. We can say, is there a patient with a certain ID? And this again is a very efficient operation because we're going to run our hash function on this number. That will give us an index, and we'll just check that index in the array. So let's see what that looks like with this code here. So we're going to check and say, is this key there, 443900? And It's not in there, so this one should print out there is no patient with ID 433900, and we're doing this by calling the contains key method. That's the method here that allows us to say, does this thing exist in the map? And indeed, it says there is no patient with ID 443900 because this returned false. Let's see what it looks like when we ask it if something is there that is there. So here we're asking, does the map contain key 876540, which it should. That should be the key Byron. So let's see. And here it says, yes, there is a patient with ID 4. Oops, I think I copied this wrong. There's a patient with ID 876540. I messed that up. Let me fix that. Okay, run that again. So in fact, there is a patient with ID 876540, and that's the patient Byron. All right. Let's do the other, the other search, and this is the contains value. So contains value is not efficient because it's going to go through everything that's in the hash map, and it's going to look to see if this is there. So let's do this. And the way we do this is we have to create a patient that's the same as one that we already have. This is Abby, status is minor, and that's the ID, and that's the same as what we have down here. Status is minor, and that's the ID, okay? And we're gonna say, does our map contain this value, and give it this patient. So again, we're not giving it the key, we're just giving it this whole patient object, right? So let's run this. And it says Abby doesn't exist. This didn't return true, and yet we know that we have a patient like this. And that's an important point that I want to share with you. In order for the contains value method to work, the value objects, the class of that object, has to override the equals method. Okay, so let's go back to our patient class, and down here I've got an override that I commented out. So the equals method is part of the Java object, and you can override it in any class you create. It's got to return a Boolean, and it takes an object. And this is similar to a compare to method, except you're just returning true or false, whether the two objects are the same. But you get to say on what basis you're going to say two objects are the same. So this is not going to compare pointer memory locations. This is actually using the data inside the object to say, yeah, I consider these two objects to be basically equal. And we want to consider patient objects to be equal if the name and the patient ID match. So here I'm checking to make sure that the object passed in is actually a patient, and then I'm doing a cast, and then I'm checking name is the same as get name, ID is the same as get ID. If both of those are true, then I'll return true. Otherwise, I'm going to return false. So now that I've uncommented this, if I go back and I run my simulation again, it should actually use that equals method to do the comparison. And now it says Abby exists. So now we know that this contains value method is working because the class that we use for a value actually overrides equals. So that's good, but in general, we probably want to avoid using this method, the contains value method, because it's not efficient. It's going to search through every item into the hash map until it finds one that actually matches the object you pass in. We really prefer to do contains key. All right. What happens if we map something else to the same key? So right now, 456754 maps to the patient John. And if we change it and we do a put with the same key and put in a different patient, then it's actually going to override John. So let's look and see what happens there. So initially 456754 maps to John, and we can see that because we're doing a get, right? And we get John. And then when we put something, a new patient with the same key, and then we do another get, we'll see that now 456754 now maps to the patient Abdul. Okay, and here it's important to note that we gave Abdul a different ID in his actual patient record. It's not the same as this, so you can tell that we're not actually looking at this ID inside the patient record. We're looking at the key that's passed in. All right, finally, I want to show you what happens when we have a collision. Now, keep in mind that collisions will be taken care of by the hash map that's built into Java, so we don't have to really worry about this or detect it, but I just want to prove to you that even if collisions are happening, everything's still going to work fine. So the way that I'm proving this to you is, remember that when we declared the hash map, we said it's going to have 131 slots in the array. That means our hash function is probably going to do a modulo of 131. And so I found two numbers that are evenly divisible by 131, and so they would create a hash index of 0. 710413, 811938. You can check with your calculator. Both of those, if you modulo 131, you'll get 0. And so they should actually collide, and both of these patients, if we use these keys and put patients in with these keys, they should both end up in the same slot in our table, which is a collision, and so the hash map should create a chain. So I've created a patient Krista with patient status minor and this ID, so they both have the same patient ID, and I've put in a key value of 811938, and then I've put in another one, key value 710413, with a different patient named Durin and a different status, etc. And we'll see that they both actually end up in the map, and one of them, Durin, doesn't override or overwrite Krista. Krista will still exist. And I'll actually copy this line just to show you afterwards, even after we put Durin in, that Krista still exists. Okay, so we put patient Krista in with this ID, and then we put patient Durin in with this key, and both of these keys will hash to the same index, but they're both still going to exist because even after I've added Durin, and then I print out the pm.get with Krista's key, which maps to the same index, I'm still getting Krista. So the Java hash map is handling collisions on our behalf and will create a linked chain of patient objects in that array slot to hold both Krista and Durin in that slot. Okay, so that's an example of how you can use Java's built-in hash map function to store a bunch of stuff and get really quick access to values based on giving the map the key that you want. Okay, thanks a lot for watching.